Download this code from codegive.com, link in the description below. Understanding and handling class-cast exception in Java, a comprehensive guide. The class-cast exception in Java is a runtime exception that occurs when you try to cast an object to a type it's not compatible with. It's a common issue, especially when dealing with inheritance, polymorphism, and generics. Understanding the root causes and proper handling techniques is crucial for writing robust and error-free Java code. 1. What is class-cast exception? Imagine you have a box labeled apple. You can put an apple in that box without any problem. However, if you try to put an orange in the apple box, it doesn't fit, and something goes wrong. That something going wrong is similar to what happens when a class-cast exception occurs in Java. Specifically, class-cast exception is thrown when the Java Virtual Machine, JVM, detects an invalid cast operation during runtime. This happens when you're attempting to cast an object of one class to a completely unrelated class, for example, trying to cast a string object to an integer. You're attempting to cast an object of a superclass to a subclass without the object actually being an instance of that subclass. This is particularly common when working with inheritance hierarchies. Using generics, type erasure can sometimes lead to unexpected casts at runtime. 2. The root causes of class-cast exception with examples. Let's delve deeper into the common scenarios that lead to this exception. A. Incorrect type casting between unrelated classes. This is the most straightforward case. You simply try to treat an object as something it isn't. Explanation We create an object reference and assign a string object to it. Remember that string implicitly inherits from object. We then try to cast the object to an integer. This is illegal because string and integer are not related in a way that allows direct casting. A string is not an integer, and vice versa. The class-cast exception is thrown at runtime during the cast operation, integer, obj. The catch block handles the exception and prints an error message. Output B. Downcasting without proper instance check, inheritance. This situation is more subtle. It involves inheritance and the concept of downcasting, casting from a superclass to a subclass. Explanation We have an inheritance hierarchy, animal is the superclass, and dog and cat are subclasses. Upcasting animal 2 equals new dog, this is valid. A dog is a animal. This is called upcasting and is generally safe. Downcasting dog 1 equals, dog, animal 1, this is where the problem arises. We are trying to cast animal 1, which is a plain animal object, to a dog. Since animal 1 is not actually a dog object, the class-cast exception is thrown. The JVM checks this at runtime. Instanceof operator The instanceof operator is crucial for safe downcasting. It allows you to check if an object is an instance of a particular class before attempting to cast it. The example shows how to safely downcast animal 2 because we first confirm it is a dog using animal 2 instanceof dog. Output C. Generics and type erasure Generics allow you to parameterize classes and methods with types. However, due to type erasure in Java, the type parameters are removed during compilation. This can sometimes lead to class-cast exception if you're not careful. Explanation We create a list without specifying the type parameter, a raw type. This is generally discouraged because it bypasses compile time type checking. We add both a string and an integer to the list. Because it's a raw type, the compiler doesn't complain. Asterisk we then try to assign this raw list to a list string. The compiler issues an unchecked conversion warning because it can't guarantee that all elements in the raw list are actually string objects. Asterisk when we try to retrieve the second element, which is an integer, and assign it to a string variable, string str equals string list.get, 1, a class cast exception is thrown. At runtime, the JVM finds an integer where it expects a string. Output asterisk. Why did this happen with generics? Due to type erasure, at runtime, the JVM only sees a list. The type parameter string is removed during compilation. The cast to list string doesn't actually perform any runtime type checking on the elements within the list at the point of the cast. The problem surfaces when we try to use the list as if it only contains string objects. A corrected generics example asterisk. To avoid this, use generics properly. Explanation asterisk. Asterisk we now create a list string properly. Asterisk the compiler prevents us from adding an integer to the list. This is the benefit of generics, they provide compile time type safety. Asterisk because we are only adding string objects to the list, there is no risk of class cast exception at runtime. D. Issues with arrays asterisk. Arrays in Java have covariant types. This means that if sub is a subtype of super, then sub is a subtype of super. However, this covariance only applies at the array type level. The actual array elements are still subject to type checking at runtime. Explanation asterisk. Asterisk we create a string array and assign it to an object reference, covariance. This is legal. Asterisk we try to store an integer into the object, which is backed by a string. The JVM throws an array store exception at the point of assignment, objArray2 equals 123, because it knows that the underlying array is supposed to hold string objects. Asterisk the cast to string is allowed at the array type level due to covariance. However, if we then access an element of the array that is not a string, a class cast exception will be thrown. Output asterisk. 3. How to prevent class cast exception. Here are several strategies to prevent class cast exception. Asterisk use instancy of operator for safe downcasting. Asterisk always check if an object is an instance of the class you're trying to cast it to before performing the cast. This is the most common and effective way to avoid this exception. Asterisk use generics properly. Asterisk leverage generics to enforce type safety at compile time. Avoid raw types. Define the type of data stored in collections, and the compiler will prevent you from adding incorrect types. Asterisk design inheritance hierarchies carefully. Asterisk make sure your class hierarchy is well defined. Avoid unnecessary casting between unrelated types. Refactor code if downcasting becomes too frequent or cumbersome. Consider using interfaces instead of inheritance in some cases. Asterisk avoid casting unnecessarily. Asterisk before casting, ask yourself if the cast is truly necessary. Could you achieve the same result using a different approach, like polymorphism or method overloading? Asterisk defensive programming. Asterisk if you absolutely must perform a cast, even after checking with instancy of, consider wrapping the cast in a try-catch block to handle the class cast exception gracefully. This is often a last resort. Asterisk thorough testing. Asterisk write unit tests that specifically check the casting operations in your code. These tests can help you catch potential class cast exception before they occur in production. Asterisk code reviews. Asterisk have other developers review your code to look for potential type casting issues. A fresh pair of eyes can often spot errors that you might have missed. 4. Handling class cast exception. While prevention is ideal, sometimes you might need to handle classCastException gracefully if you cannot entirely eliminate the possibility of it occurring. Explanation asterisk. Asterisk we use a try-catch block to wrap the potentially problematic cast. Asterisk if a classCastException occurs, the catch block handles it. In the catch block, you should asterisk log the error, record the exception details for debugging purposes. Use a logging framework like log4j or slf4j. Asterisk provide informative error messages to the user, if applicable. Asterisk implement error recovery, attempt to recover from the error if possible. For example, you might retry the operation with different input or use a default value. Important considerations when handling exceptions asterisk. Asterisk don't catch exceptions just to swallow them. Asterisk catching an exception without doing anything about it can mask serious problems in your code. Always log the exception, take corrective action, or rethrow the exception. Asterisk catch specific exceptions. Asterisk catching exception or throwable is generally discouraged because it can hide other types of errors. Catch the specific exception that you expect, such as classCastException. Asterisk use finally blocks. Asterisk if you need to execute code regardless of whether an exception is thrown, example to release resources, use a finally block. 5. Debugging classCastException. When a classCastException occurs, the error message will usually tell you asterisk the class that you were trying to cast from. Asterisk the class that you were trying to cast to. This information is invaluable for debugging. Use the following steps. 1. Examine the stack trace. Asterisk the stack trace will show you the exact line of code where the exception was thrown. This is your starting point. 2. Inspect the object's actual type. Asterisk use a debugger or system.out.println, object getClass, .getName, to determine the actual type of the object you are trying to cast. This will confirm whether the object is compatible with the type you're casting to. 3. Review the code around the cast. Asterisk carefully examine the code leading up to the cast. Where did the object come from? What operations have been performed on it? Is there any possibility that the object's type has changed unexpectedly? 4. Check for generic type issues. Asterisk if you are using generics, make sure that the type parameters are being used correctly. Pay attention to unchecked conversion warnings. 5. Use breakpoints and debugger. Asterisk set breakpoints in your code and use a debugger to step through the code execution and inspect the values of variables. This can help you pinpoint the exact moment when the object's type becomes inconsistent. In summary, classCastException is a runtime exception that indicates an attempt to cast an object to an incompatible type. Preventing this exception involves using the instanceOf operator, leveraging generics, designing inheritance hierarchies carefully, and writing thorough unit tests. When you cannot prevent it entirely, handle the exception gracefully with a try-catch block, log the error, and attempt to recover from it. Understanding these principles will help you write more robust and reliable Java code.